All right, for this circuit, we are going to find the current. When it comes to multi-loop circuits, you want to make as many equations as you have unknowns, because what we're going to do is make a system of linear equations with our unknowns, and then we can make it easy on ourselves to put it into a matrix in our calculator, and then have our calculator put the matrix into reduced row echelon form, and that will make it a quicker solve. For the equations, we're going to look at this circuit 4. It's important that we have at least one junction equation and 2 loop equations. So for this, I'm going to make my junction equation first. So my junction equation, if I look at this junction, I have I1, and then I2 and I3 come out of I1, and then I3 and I2 come back together to make I1. So my junction equation here is going to be I1 equals I2 plus I3, and then I can rewrite it as I1 minus I2 minus I3 equals 0. So that is going to be my first equation in my system. For my second equation in the system, I'm just going to do the big loop around this way, and then I'm going to start right here. So my big loop, I'm going to go through, I'm going to add V1. So I have V1, and then as I go around, I'm going to add V2 plus V2, and then I'm going to drop I3R3, so minus I3R3, and then I'm going to drop I1R2 minus I1R2, and then I am back to my starting point, so that is equal to 0. So I actually have some values here. So we have 1.6 plus 1.4 minus 1 times 10 to the third I3 minus 1 times 10 to the third I1 equals 0. 1.6 plus 1.4 is 3. So what I have here is negative 1 times 10 to the third I1 plus 0 I2 minus 1 times 10 to the third I3 equals negative 3, because I added this together to get 3, and then I subtracted it over here. I wrote this like this with the 0 I2 just so we can see what our system of linear equations is going to look like. So this is our second equation. We have 3 unknowns here, so we need 3 equations. So we need one more equation, and then I'm gonna do this small left-hand loop. So left loop, I add V1, so V1, and then I come through and then I drop I2R1 minus I2R1, and then I come back around and then I drop I1R2, and then I'm back to where I started, so that is an equals 0. So I have 1.6 minus 2 times 10 to the third I2 minus 1 times 10 to the third I1 equals 0. And then I'm going to rewrite this as negative 1 times 10 to the third I1 minus 2 times 10 to the third I2 minus 0 I3 equals negative 1.6. So these are our 3 equations here. So we're going to make a matrix. And then our matrix is going to look like, I'm going to put this equation. So the coefficients of all the i's here are just 1, -1, and -1, and that's equal to 0. So my entries are going to go 1, -1, -1, and 0. My second equation, my entries are going to be -1 times 10 to the third, 0, -1 times 10 to the third, and then -3. So I have -1 E3, 0, -1 E3, and then -3. And then here I have -1 times 10 to the third, so -1 E3, -2 E3, 0, let's put a plus there, and -1.6. So what we're going to do is put this matrix into our calculators and then have our calculators put it in. All right, so I have my TI-84 graphing calculator here. So what I'm going to do now is put this matrix into my calculator and then have my calculator put it into reduced row echelon form. So I'm going to hit second and then hit matrix here. And then I'm going to hit edit and then I'm going to hit enter. This is a 3 by 4 matrix. So 3 by 4. And then I'm going to put in my entries. So we have 1, -1, -1, and 0. -1 E3. Oh, this one doesn't like scientific notation. So -1000. All right. 0, -1000, and then -3. And then we have -1000, -2000, 0, and then -1.6. All right, I'm going to quit here. And then I'm going to go back into the matrix menu, and then I'm going to hit math. And then we want to find RREF, so reduced row echelon form. Then I'm going to go back into the matrix menu. I'm going to select my matrix A, and then what reduced row echelon form does is it finds us a solution for each variable. So when we read this, that first line was 1, so that's 1I1, and that is 1.52 times 10 to the -3rd. So I1 is 1.52 times 10 to the -3rd amps. The second row, that 1 is where I2 was. So I2 is equal to 4 times 10 to the -5 amps. And that last row, that 1 is where I3 was. So I3 is equal to 1.48 times 10 to the -3rd amps. So that tells us what each current is. So if we look back at our original circuit, we defined I1 as here. So I1 is going through R2. So that means that the current through R2 is 1.52 times 10 to the -3 amps, or 1.52 milliamps. I2 is going through R1, so that means the current through this 2000 ohm resistor is 0.04 milliamps, 4 times 10 to the -5 amps. And then the current through this resistor is I3, 1.48 times 10 to the -3 amps. Once we have all these currents, then we can go through and we could find the individual voltage drops across each resistor,